Wave-particle duality is one of the most fascinating concepts in quantum physics, and it challenges everything we think we know about the nature of reality. At its core, this idea suggests that particles, like electrons and photons, can exhibit both wave-like and particle-like properties depending on how we observe them. One of the most famous experiments that illustrates this duality is the double-slit experiment. Imagine firing a stream of particles, say electrons, at a barrier with two slits. When both slits are open, something remarkable happens. The electrons create an interference pattern on a screen behind the barrier, much like waves do when they overlap. This pattern suggests that each electron is behaving like a wave, passing through both slits simultaneously. However, when we try to measure which slit an electron goes through, the interference pattern disappears, and the electrons behave like particles, creating two distinct bands on the screen. This experiment raises profound questions about the role of the observer in the quantum world. The implications of wave-particle duality extend beyond just quirky experiments. Albert Einstein and Louis de Broglie were pivotal in shifting our understanding of physics. Einstein introduced the idea that light can be thought of as both a wave and a particle, which was revolutionary. De Broglie took this further, proposing that all matter has a wavelength associated with it, now known as the de Broglie wavelength. This means that even massive particles, like electrons, have wave-like properties, which is a cornerstone of quantum mechanics. So, what does this mean for us? Wave-particle duality challenges our classical intuitions about the world. It suggests that reality is not as straightforward as it seems. In the quantum realm, particles exist in a state of probability until observed, which implies that our act of measurement plays a crucial role in shaping reality. This idea can be mind-boggling as it blurs the lines between observer and observed, raising philosophical questions about the nature of existence itself. In practical terms, wave-particle duality has real-world applications. It underpins technologies like semiconductors and lasers, which are foundational to modern electronics and telecommunications. Quantum mechanics, driven by these principles, is also paving the way for advancements in quantum computing and cryptography, potentially revolutionizing how we process and secure information. As we delve deeper into wave-particle duality, we uncover mind-blowing truths about the universe and our place within it. It invites us to embrace uncertainty and complexity, reminding us that our understanding of reality is still evolving. So, let's stay curious and open-minded as the mysteries of quantum physics continue to unfold, revealing a universe that is far more intricate than we can imagine